Hello, welcome to the Section 2.3 lecture video. Today what we're going to talk about is building off what we've been talking about. In the last section we talked about limits. And specifically what we talked about was the definition of a limit and how to find limits. But unfortunately this process does not allow us to prove that the value we find is the limit of the function that it approaches. So that's what we're going to talk about today, is what's called the precise definition of limits, how to prove the value of a limit. So once again, you can find the Chapter 2 handout on Blackboard or MyMathLab. And if you want to follow along with that, you can, but make sure you're taking notes and treating this just like we're in class. So, the precise definition of limits. So let's look at an example to start us off here. So, consider the function y equals 2x minus 1, near x equals 4. Intuitively, it seems clear that y is close to 7 when x is close to 4, right? Because if you plug in 4 into the function, 2 times 4 is 8, minus 1 is 7. So we could say that the limit as x approaches 4 of 2x minus 1 equals 7. However, how close to x equals 4 does x have to be so that y equals 2x minus 1? Differs from x by, say, less than 2 units. So the idea here is what we like to work out is the idea of, if we give this a range, if we fix a range around the function that we want to be from that limit, can we always find a range around x that would work? So in this example, what we've got is we've got a graph that looks something like this. Okay, and so we know in this case that we have this point 4 comma 7. And so the idea is, if we restrict, so here's 7, if we restrict our area, a region around this within 2 units, that would be 5 to 9, what do we have? Can we find a corresponding region for x that x has to fall in to make that happen? And we can, right? If I bring this over to the function, it looks like this, and then I can bring it down to the x-axis. So here I've got 4, and to be at 5, we'd plug in the number 3, and to be at 9, we'd plug in the function 5. So what we're saying is, we found a region around the y value, around f of x, that went from 5 to 7, and we were able to find 5 to 9, sorry. I found a corresponding region from 3 to 5. So the idea behind the precise definition of limit is that if I find any region like this one, no matter how small, can I always find this region around x? And if I can prove that this region on the bottom always exists, then we've proven that the limit is what we said it is. So the definition: let f of x be defined on an open interval about c, except possibly at c itself. We say that the limit as x approaches c of f of x, and write the limit as x approaches c of f of x equals L if for every number epsilon greater than 0, there exists a corresponding number delta greater than 0, such that the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus c is less than delta. Okay, so these are the Greek letters, lowercase Greek letters for epsilon and delta. And so the idea is, if whenever I have a region around the limit, around the y value of the limit, f of x, I can find a corresponding delta value, a region around the x values that matches up. And I can do that for anything, where basically we can do that if we allow epsilon and delta to remain variables. So the formal definition of the limit does not tell us how to find the limit of a function, but it does enable us to verify that a conjectured limit value is correct. So one of the ideas we want to start with is this idea of sketching an interval around on the x-axis around our point C, and then being able to find our delta value. So for example here, my region is, let's draw a better line than that. So I've got my number line, I've got my A and my B, so 1 is A, B is 7, and then C is 2, okay? So the key thing here is, can we find a delta value that falls within that? Whoops, I kind of wrote these backwards. Let me fix this one. Okay, so C is 2. So can I put an interval around C with an equal delta value that fits within this bigger region, right? So if I've got this region here, what I'd like to do is pick a delta value that would allow me to make a region that goes inside of that around C with a certain width delta. Well, the biggest delta could be is 1, right? Because if delta, these are 1 apart, these are 6 apart. If I make delta 1, then I get this region. If I make delta 6, I get a region that looks like that. Is the blue interval within A and B? No. But the green interval is. So if we let delta equal 1, and our interval be 1, 3, then that would work. And that's what we're looking for. Is we're fitting based on, we'll be given a region like 1, 7 from epsilon, and we want to find a delta that would fit within that region. Okay, so to give you another example of this, this one has a typo. This was supposed to be 7 halves, negative 7 halves. So if we do this one, right, we've got negative 7 halves over here. That's our A. Our B is negative 1 half. And our C is negative 3 halves. And so to figure out our delta again, we just want to pick the smaller of the two distances. So in this case, the distance from negative 7 halves to negative 3 halves is 2. The distance from negative 3 halves to negative 1 half is 1. So just like in the first example, delta would equal 1. In this case, our region would be from negative 5 halves to negative 1 half. Okay, so that's the idea. So why don't you all take a moment and pause the video and try the last one. Okay, so now you've tried this one. The last one would look like this. We've got A is 1. B is 7, and C is 5, right? So this distance is 2, this distance is 4, so our delta would have to be 2, and our region would go from 3 to 7. So that's all there is to that. That's kind of a very basic start to what we're talking about here. So the next thing we want to be able to do is we want to be able to find delta values given a fixed epsilon, before we start building into the idea of finding, doing this in general, okay, and when we don't know exactly what our epsilon is, okay. So what we're given here is, for each exercise gives a function f of x, the number L, C, and an epsilon greater than 0. In each case, find an open interval about C on which the inequality, the absolute value of x minus L is less than epsilon holds. Then give a value of delta greater than 0 such that for all x satisfying 0 is less than x minus C is less than delta, the inequality, the absolute value of x minus L is less than epsilon holds. Okay, so what we want to start out with is we want to start out with this idea. F of x minus L is less than epsilon. So plug in our values for that. So in this case, that would be the square root of x minus 7 minus 4 is less than 1. Okay? So what we really want to do now is we just want to rewrite this so that it matches this. So that we can make it match the absolute value of x minus c is less than some delta. Okay, so we want to rewrite the middle as an interval that involves this x minus c idea. So to do that, the first thing we do is get rid of the absolute values. So if you remember back to college algebra, when you have the absolute value of something is less than a number, that means that expression has to fall between the number and its opposite. So that would be negative 1 is less than the absolute value of x minus 7 minus 4, which is less than 1. And then we can try and start solving down to this idea of x minus c. And we might have to add the c in at the end, or the c might appear. In this case, the c is 23. Okay, so add 4 to all the pieces to start trying to get the x by itself in the middle. So that's 3 is less than the square root of x minus 7, which is less than 5. And now we could square the whole thing. So that's 9 is less than x minus 7, which is less than 25. Okay, and then we could add 7 to all 3 pieces. So that would be 16 is less than x, which is less than 32. Okay, and so now this would give us our region around our x, around our c. So the region here, assuming c is in there, would be 16 to 32. And then your delta, just like remember on the last page, is whichever of those two numbers is closer to the value, to our c, to 23. So you just want to take 32 minus 23 and 23 minus 16. So 32 minus 23 is 9. And 23 minus 16 is 7. So delta equals the smaller one, which is 7. Okay, and so that's all we're trying to do here. Okay. Okay, so let's try. Hold on, I want to just check one thing. Yep. Okay, so let's try one more. Or a couple more together. So the next one, same idea, right? So start off by doing the absolute value of f of x, so x squared minus 5 minus L, which is 11, is less than epsilon. And the first thing we want to do is just solve for c. So this will be negative 1 is less than x squared minus 5 minus 11 is less than 1. Combine like terms. So this is negative 1 is less than x squared minus 16, which is less than 1. And then you can add 16 to both sides. So this is 15 is less than x squared, which is less than 17. And then you can take the square root of all 3 pieces. So this is the square root of 15 is less than x, which is less than the square root of 17. So our interval is the square root of 15 comma the square root of 17. And now we just need to figure out which one of those is closer to our value, and that'll give us our delta. So we'll take the square root of 17 minus 4 and 4 minus the square root of 15 and see what those values are. So we can do those in the calculator. And so I get 0.123 and 0.127. So this was approximately 0.123. This was approximately 0.127. So the smaller one is 0.123. So delta is the square root of 17 minus 4, which is approximately 0.123. Okay, so that's the idea. And we could even do this kind of thing in a little bit more generalized fashion. So in this case, I've got a lot more variables going on. So I've got my function is a line. And then I've got my limit, and then I've got my c value and my epsilon. So we set it up the same way. The absolute value of f of x, so mx plus b, minus L, so m over 2 plus b, is less than our epsilon, which we're calling c. Okay. So we can simplify and get rid of the absolute value. So negative c is less than mx minus m over 2, right? Because b minus b is 0, so those are going to cancel, which is less than c. And we're trying to solve for x, so add m over 2 to both sides. So m over 2 minus c is less than mx, which is less than c plus m over 2, and then divide by m. So m over 2 divided by m is 1/2, minus c divided by m, which is less than x, which is less than c divided by m plus 1/2. And so in this case, our interval, right, is going to be 1/2 minus c over m, comma, c over m plus 1/2. And if you take those minus our c, so 1/2 minus 1/2 minus c over m, so the 1/2 minus the smaller one, and then the bigger one minus 1/2. In both cases, you get c over m. So my delta is c divided by m. Okay, and so that's the idea. So what I'd like y'all to do now is flip to the next page and pause the video for a moment and try doing the exact same thing we just did for these 3 examples. Okay, so now that you've all tried them, let's go ahead and run through them together. So they all start out the same way, right? So f of x, so 2x minus 2 minus the limit is less than epsilon. Okay, so now we can combine like terms and get rid of the absolute value. So negative 0.02 is less than 2x minus 8, which is less than 0.02. Add 8 to all the pieces and you get 7.98. It's less than 2x, which is less than 8.02. Divide by 2 and you get 3.99 is less than x, which is less than 4.01. So our interval is 3.99, 4.01. And now we can subtract those from our c. Oh, shoot. I did something wrong. Okay, let's erase this. Sorry, I made a mistake. Because it's minus L, so I needed minus a negative 6. So this should be negative 0.02 is less than 2x plus 4, which is less than 0.02. Now subtract 4, and you get negative 4.02 is less than 2x, which is less than negative 3.98. Divide by 2 and you get negative 2.01 is less than x, which is less than negative 1.99. And now, just to go back for a second, I noticed that I was wrong. Something had gone wrong because c wasn't in my interval before. But c is between these two numbers, so I'm okay now. So this would be negative 2.01, comma, negative 1.99. And now we can do the same thing we've done before, which is take negative 2 minus negative 2.01 and negative 1.99 minus negative 2 and see what we get. In either case, we're going to get 0.01. So our delta is 0.01. So we got the same thing for both, so you could use either side. Okay? And then for the next thing, next one, same idea. So let's go ahead and try this one. So start out by taking f of x minus L is less than epsilon. And then get rid of the absolute values. And then add 3. And then take the square root. So we can use the calculator here to do that. Square root of 2.9 is 1.703. Square root of 3.1 is 1.761. Or you can just leave them written like this. Either way. When you're doing the homework, just make sure you're inputting your answers the way they ask for them. And then to find delta, we just take the square root of 3 minus the square root of 2.9 and the square root of 3.1 minus the square root of 3 and see which one is smaller. So there we can use the calculator. So square root of 3 minus square root of 3 minus the square root of 2.9 is 0.029. And on the other side, we get 0.0286. So we need around a 4 decimal places here, right, to find the difference. But it's 0.0291 and 0.0286. So it's the second one. So delta equals 0.0286. And once again, write your answer in the format they asked for on the homework. And then the last one. Okay, so set it up exactly the same way, right? So 1 over x minus negative 1 is less than epsilon. Okay, so that's negative 0.1 is less than 1 over x plus 1, which is less than 0.1. Subtract 1, you get negative 1.1 is less than 1 over x, which is less than negative 0.9. And then what you have to do is you need to take the reciprocal of everything to flip all of these over. Okay, so we want to take the reciprocal of negative 1.1. So that's 1 divided by negative 1.1, which is, and you may want to use this as a fraction, maybe easier, so it's negative 10 over 11. And then the other one is 1 divided by negative 0.9. And once again, it may make the most sense to write this answer as a fraction. So we get negative 10 elevenths is x, and then negative 10 ninths. And then because we did the reciprocal, that actually also flips around the inequality symbols. So we get like this. So our final answer here is going to be negative 10 over 9, comma, negative 10 over 11. And then we do the same thing we did before. We take negative 1 minus negative 10 over 9 and negative 10 over 11 minus negative 1. So that's going to give us 1/9, and this one gives us 1/11. 1/11 is smaller, so delta is 1/11. Okay, so that's the idea. So that's how we do this when we're given a fixed epsilon value to go along with our x and our c. Now, one way we could take this a little bit step further is when you do this in the real world, what you're usually going to do it with is you're going to find a limit and then prove the limit is what you think it is. So the next step we could add in here is the idea of finding a limit to that, and that just adds a step at the beginning, right? Because so the first thing I want to do in this first one is I need to find the limit. So the limit as x approaches c, in this case c is 2 of x squared minus 4 over x minus 2. So we learned in the last section the way we do that is we first need to factor it. So this would be the limit as x approaches 2 of x minus 2 times x plus 2 over x minus 2. We can cancel out the x minus 2's, and so we can plug 2 into this function and we get the limit is 4. So that's the only step that's any different. I had to find the limit. Now once I found the limit, the steps are all the same as the problems on the previous page. So I take the absolute value of f of x, and when you're doing this, it's probably a good idea to go ahead and use, you can save yourself some time if you're using the simplified form you already found. So x plus 2, right, because we were able to simplify that, minus our limit, which is 4, is less than our epsilon of 0.05. So then that's negative 0.05 is less than x minus 2, which is less than 0.05. Add 2 to all the pieces, and you get 1.95 is less than x, which is less than 2.05. And so that's our interval, which they're not actually asking us for in this case. They really just want to find our delta. And so there's actually a step here I did that I didn't necessarily need to do. Because if you go back a step, notice that what we're looking for is the absolute value of x minus c is less than delta. In this case, x minus c would be x minus 2 is less than delta. Well, where do you see an x minus 2? Right here in this step. So I could actually skip this step and just go ahead and use the answer I had in the previous one. Or if you didn't ever see that step, what you would do is just subtract 2 from all 3 pieces, or work the same way we've been working before, which is figure out which one's closer to delta. So however you want to go about it. So there are 2 ways to know. So if we do this the same way as the previous problem, then what I do with this x minus thing is I just take 2.05 minus 2 and 2 minus 1.95, and I get 0.05 or 0.05, and so the answer is the same for both. So you could do it the same way we did the last problem, or you can notice in the previous step that my x minus 2 was between 2 numbers and whichever one is closer. In this case, they're the same distance, so the answer is 0.05. So you could have saved yourself a couple of steps if you recognize that. Okay, so let's try another one. So the next one, start out once again by finding the limit. In this case, the limit is x approaches negative 3 of the square root of 1 minus 5x. So that's all we have to do is plug the number in. So the square root of 1 minus 5 times negative 3. So that's the square root of 16, which is 4. Okay. And so now we can go to the next step. So this would be the absolute value of the square root of 1 minus 5x minus 4 is less than 0.5. So that's negative 0.5 is less than the square root of 1 minus 5x minus 4 is less than 0.5. Add 4 to all the pieces. So this is 3.5 is less than the square root of 1 minus 5x is less than 4.5. Square those. So 3.5 squared. Oops. Sorry, that's in the wrong problem. 3.5 squared is 12.25, and 4.5 squared is 20.25. So 12.25 is less than 1 minus 5x, which is less than 20.25. Subtract 1 from those, so 11.25 is less than negative 5x, which is less than 19.25, and then divide by negative 5. So I'm going to go and do that with the calculator. So 11.25 divided by 5 is 2.25, so it'll be negative 2.25, and 19.25 divided by 5 is 3.85. So negative 2.25, and whenever you divide by a negative, you have to flip the inequalities, right? So this will be negative 2.25 is less than x, which is less than negative 3.85. And now notice in this case, we never had x minus x plus 3 show up, so we have to do it the same way as the ones before. So take negative 3 minus negative 3.85, which is 0.85, and negative 2.25 minus negative 3, which is 0.75, and whichever one is smaller is our delta. So in this case, it's that one. Okay, so that's the idea. So at this point, go ahead and pause the video for a moment and try the last 2. Okay, so if we go ahead, now that you've tried these, let's go through them together. So start off by finding the limit. So in this case, that's just plugging in the number. So that's negative 3. So this will be 3 minus 2x minus a negative 3 is less than 0.02. So that's negative 0.02. Combine like terms. So that's less than 6 minus 2x. Whoops, sorry, no absolute value there. 6 minus 2x is less than 0.02. Subtract 6 from both sides and you get negative 6.02. It's less than negative 2x, which is less than negative 5.98, and divide by negative 2. So that'll be 3.01 is greater than x, which is greater than 2.99. Okay, and so in this case, delta, these are both 0.01 from x, from c, from 3, so the answer will be 0.01. And the last one, same idea. So limit as x approaches negative 5, so that's x squared plus 6. And so in this case, well, I'll go ahead and write it like this. So we need a factor, so 2 numbers that multiply to get 5 and add to get 6 are x plus 1 and x plus 5. Cancel out the x plus 5s and plug in negative 5, and you get negative 4. Okay, so this will be, and once again, use the already simplified version. So x plus 1 minus a negative 4 is less than 0.05, so that's negative 0.05 is less than x plus 5, which is less than 0.05. And at this point, you could actually stop, because notice our c here, remember, it's the absolute value of x minus c is less than delta. So here we have a plus 5, which means our c is negative 5. Well, that's what our negative 5 is. So how far are these? 0.05. So this would be 0.05. And sorry, there shouldn't have been absolute value bars there, but same idea still works. Okay, and so that's kind of what we're building to, especially this part here is something we're going to use a lot. These two different ways to look at this. Okay, so the last thing we need to be able to do in this section is to do this proof idea. Okay, proving that the limit we think it is the limit it is. Now, I went ahead and found the limits for these, but it doesn't really matter which one you're dealing with. So, if we, well, you could check, right, and make sure that is the limit, right? If I plug in 9, square root of 9 minus 5 is 4, square root of 4 is 2. So that is the limit. So what we want to do is we could start out by writing out what we're looking for. So what we're going to do here is we're going to start with, we want the absolute value of f of x, so in this case the square root of x minus 5 minus L, to be less than epsilon whenever the absolute value of x minus c, so in this case c is 9, is less than delta, right? That's what we're looking for. Okay, so we need to show that. So what we're really looking for is we're looking to be able to write a statement that says, if we know the value of epsilon, this is what the value of delta would be. Or another way to say that is how to write delta in terms of epsilon. So for example here, if we go through this, so that's what we're starting with. So we've got the absolute value of the square root of x minus 5 minus 2 is less than epsilon. And we're going to look at these problems just like the ones we were doing before. So I can get rid of the absolute value bars. So this is negative epsilon is less than the square root of x minus 5. Minus 2 is less than epsilon. And then we're going to add 2 to both sides. Right, and now I'm going to square both sides. So this will be, if I square this side, it's epsilon squared minus 4 epsilon plus 4 is less than x plus 5, which is less than epsilon squared plus 4 epsilon plus 4. And then subtract, at this point, remember what we're trying to make. What we're trying to make is we're trying to make x minus 9. So there's a couple ways you could go about this. Yeah, well, never mind. I'm going to take that back. Don't do what I was kind of saying there. But anyway, so go ahead. Oh, whoops. Sorry. Somewhere in here, this x minus 5 became an x plus 5. So I can go back to what I was saying. Okay, so these should be x minus 5s. Okay, so we're trying to make epsilon x, we're trying to make x minus 9. So I already have x minus 5, so make that into minus 9, I just need to subtract 4 from it. If I'm going to subtract 4 from the middle one, I need to subtract 4 from the outside ones. And so what we get is epsilon squared minus 4 epsilon is less than x minus 9, which is less than epsilon squared plus 4 epsilon. Okay. And so now we end up with an interesting case. So we've got our thing in the middle, and delta is going to be whichever one of these is smaller. And so that's simply what we can say. We can say delta equals the minimum value of epsilon squared minus 4. I need to use brace here, sorry. I used the wrong notation. Epsilon squared minus 4 epsilon and epsilon squared plus 4 epsilon. Okay, and what we really want to do is we're just kind of curious what happens as those get close to 0, right? Because we're trying to make those close to 0, so we can use a graph to see which one of those is smaller. So if I graph these using x in place of epsilon, so the calculator will graph it, right? The calculator will only graph this if I'm using x's. So it's x squared minus 4x and x squared plus 4x. Okay, and the key thing here is we want to know what happens when we get close to 0. Because remember, both our epsilon has to be positive, and so does our delta. Okay, so if we look at this, notice that if we let delta be the first one, the orange one, as we get close to 0, it would actually be negative, and that's a problem. So that's a no-no. So if we come back here and we look at these, and I can keep talking about them. So as epsilon approaches 0, let's write it that way. So using the arrow notation that we've been using for approaches, epsilon squared minus 4 epsilon is negative. So delta has to be equal to epsilon squared plus 4 epsilon. Okay, because delta, and I forgot to write this up here, but delta has to be greater than 0. Right? That's one of the things we said about epsilon and delta. So there's our answer. And because that always exists, like epsilon squared plus 4 epsilon is always a positive number, and it for numbers greater than 0, and it's always no matter what I pick for epsilon, that always exists. So that's a fine answer. So the key here is this epsilon is always exists and is greater than 0 when epsilon is greater than 0. And that's what we're looking for. And so no matter how small I make epsilon, I'll be able to find a delta that matches up with that. Okay? Okay, so let's try another one together. So the second one, we start out the exact same way. Okay? So this will be the absolute value of x squared minus 9 over x plus 3 minus negative 6 is less than epsilon. And we're in this case, we're looking for 0 is less than the absolute value of x minus negative 3 is less than delta. Okay? So the first thing you want to start out with here is you want to factor. Okay? To try and simplify this. So this will be x minus 3 times x plus 3 over x plus 3 plus 6 is less than epsilon. Okay? Cancel out the x plus 3's. So this is the absolute value of x minus 3 plus 6 is less than epsilon. And then if I simplify that, I get the absolute value of x plus 3 is less than epsilon. And so now you should notice these are the same. Right? If I simplify that. Right? This is the same as this. So that means in order for this to work, delta just has to equal epsilon. And epsilon, well, that's all something we can always do for epsilon. So that proves that no matter what epsilon I pick, no matter how small I make the area around the function value, I'll be able to find a region around the x value. Okay, and then the last one is piecewise function. So if you have a piecewise function like this one, so first of all, let me show you that we can graph this, what this would look like when you graph it. And we can do that with the calculator. So if I So I'm going to graph each piece. So the first piece is 4 minus 2x. And then I want to set its domain. So I'm going to click and hold on this purple circle, and it should pop up this menu, and I can pick set domain. And what I want to pick in this case is I'm pretty sure I wanted my domain to be x is less than 1. So I put in the 1 there. Yeah. Okay, 4 minus 2x with x less than 1. Okay, yeah, there it is. And so there's my graph. And now I can put in the other one. So 6x minus 4. So 6x minus 4. And I want to do that for x greater than or equal to 1. Okay? Now, the first thing we want to note here is that these two graphs at 1, okay, they're sharing that point. Okay? So that means I need to show the limit for both of these approaches that value. If only one of these functions approached a value at 1, then I wouldn't have to do both. But in this case, I do need to do both of these. Okay, so I'm going to have to do the same thing that I'm doing here, but do it for both. So for the first one, it'll be the absolute value of 4 minus 2x minus 2 is less than epsilon. Okay, so we simplify. So this is the absolute value of 2 minus 2x is, and let's go ahead and get rid of those absolute value bars. Okay, so this would be negative epsilon is less than 2 minus 2x, which is less than epsilon. Then we can subtract 2 from both sides. So this is negative epsilon minus 2 is less than negative 2x, which is less than epsilon minus 2, and then divide by negative 2. So this would be epsilon over 2 plus 1 is greater than x, which is greater than negative epsilon over 2 plus 1. And then we want it to be close to 1, so I need to subtract a 1 from the inside, so it's x minus 1, so I need to do that on the outsides as well. And so in this case, I get epsilon over 2 is greater than x minus 1, which is greater than epsilon over negative epsilon over 2. And so notice in this case, those are the same, except opposites. So in this case, delta would equal epsilon over 2. Okay? And then we do the other one. Same idea. Okay, so I'm going to do the absolute value of 6x minus 4 minus 2 is less than epsilon. So that's negative epsilon is less than 6x minus 6 is less than epsilon. Okay, subtract 6 from, add 6 to both sides. So this is negative epsilon plus 6 is less than 6x, which is less than epsilon plus 6, and divide by 6. So this is negative epsilon over 6 plus 1 is less than x, which is less than epsilon over 6 plus 1. I want c to be 1, so I need to subtract 1 from the middle, which means I also need to subtract it from the outsides. So this is negative epsilon over 6 is less than x minus 1, which is less than epsilon over 6. Those are the same, and so in this case, delta is epsilon over 6. And then you pick the smaller one, which would be this one, right? Epsilon divided by 6 is a smaller number than epsilon divided by 2. And you always want to pick the smaller one, because if the smaller one fits inside the interval, if the smaller one fits inside the interval, then it would definitely fit inside this interval, right? If delta is this small, then it's definitely smaller than epsilon over 2. And you're always trying to make sure it always fits in the interval. So you always want to pick the smaller one. Okay, so the last thing for us to try for this section is for you all to look at the next page, go and pause the video, and try these problems on your own. And then when you're done with these, we'll go through them together, and that'll be it. Okay, so now that you've got a chance to try these, let's run through them together. So the first one, 9 minus x minus 5. Sorry, I put the absolute value bar too quick. Minus 5 is less than epsilon. So that's negative epsilon equals 4 minus x. I mean, it's less than 4 minus x, which is less than epsilon. So then we subtract 4. So negative epsilon minus 4 is less than the opposite of x, which is less than epsilon minus 4. Divide by negative 1, so it's epsilon plus 4 is greater than, sorry, because I divided by a negative, so I have to flip the inequality, is negative epsilon plus 4, and then we want to get a positive 4 in the middle, so subtract 4. So this would be epsilon is less than x minus 4, which is less than negative epsilon. Those are the same distance from 0, right? So delta equals epsilon. Next one. Okay, this one is the absolute value of 1 over x minus 1 is less than epsilon. So the opposite of epsilon is less than 1 over x minus 1, which is less than epsilon. Add 1. So 1 minus epsilon is less than 1 over x, which is less than epsilon plus 1. And then take the reciprocal. So 1 over 1 minus epsilon is greater than x, which is greater than 1 over epsilon plus 1. Okay, and now we need to get the negative 1 in there. So we want to subtract 1 from all these pieces. Okay, and so that gives me 1 over 1 minus epsilon minus 1 is greater than x minus 1, which is greater than 1 over epsilon plus 1 minus 1. And now we may want to make this a little easier to deal with, but you probably could leave it alone. Okay, but if I gave these a common denominator, this would be 1 over 1 minus epsilon minus 1 minus epsilon over 1 minus epsilon is greater than x minus 1, which is greater than 1 over epsilon plus 1 minus epsilon plus 1 over itself, right? Because those are ways to really easily write 1 using these common denominators. So now I can subtract. So 1 minus 1 is 0, so those cancel. Negative epsilon would be epsilon. So this would be epsilon over 1 minus epsilon is greater than x minus 1, which is greater than, in this case, I'm going to get the 1's cancel again. So this would be negative epsilon over epsilon plus 1. Okay. Okay, and then we just need to decide, if we look at their absolute value, so their distance from 0, so we're looking at epsilon over 1 minus epsilon and epsilon over epsilon plus 1, which one of those two is going to be smaller? And so in this case, the one that's smaller is the one that has the bigger denominator, right? Because you're dividing, so this second one is going to equal delta because it's smaller, right? If you're 1 minus something is always going to be less than 1. When you divide by something less than 1, you end up with a bigger result than you started with. So it's always going to be this one. Okay, and then the last one, the thing you need to notice is this bottom part is only at one single point. So you don't even really need to worry about it for proving the limit. So to prove the limit, we're just going to do the absolute value of x squared minus 1 is less than epsilon. So that's negative epsilon is less than x squared minus 1, which is less than epsilon. Add 1, so 1 minus epsilon is less than x squared, which is less than epsilon plus 1, and then take the square root. So the square root of 1 minus epsilon is less than x, which is less than the square root of epsilon plus 1. Okay, and then you need to get it to 1, so subtract 1. So this is the square root of 1 minus epsilon minus 1 is less than x minus 1, which is less than the square root of epsilon plus 1 minus 1. Okay, and so then you just have to decide which one of those is going to be smaller. And in this case, the smaller one is at, well, first of all, one of the things you have to do is this one on the left is always negative. So you have to take the opposite of that. So it's actually going to be 1 minus the square root of 1 minus epsilon. And the other one is going to be the square root of epsilon plus 1 minus 1. And so you just have to decide which one of those is going to be smaller. And once again, if you're not sure which one's smaller, you can always graph it as we get close to 0. So if I graph 1 minus the square root of 1 minus x, and the square root of, hold on, let me check the other one. What's the other one? X plus 1 minus 1. And you can zoom in here, hopefully. And if I zoom way in, you can see that the orange one, goldish one, stays on the bottom. So the one you want to use is this one. And so that actually brings me back to one thing that I did wrong earlier in the video. So now I'm going to flip back a page for a second. When I was doing this one, I forgot to do the opposite of this value. Because it's on the left-hand side, which means it's less than 0. You always take the opposite of this value to make it a positive number, because it's always a negative number, because you're comparing this thing closer and closer to 0. So for this one should have been 4 epsilon minus epsilon squared. And so now I need to regraph these two. So x squared plus 4x and 4x minus x squared. And let me zoom out a little. Okay, and so if we look here, it's kind of hard to tell, but you can actually see the orange one is on the bottom. So in this case, my answer here was wrong. It actually should have been, I forgot a step, this one. So I'm going to erase this part. So we do the opposite of this. So that one wasn't right. So the one that's actually smaller is 4 epsilon minus epsilon squared. So that's going to be my delta, because this one is smaller. Okay, so anytime you get two answers that are different, you need to check for the one that's smaller. And always, the part I forgot about that I skipped over is always make sure you do the opposite of the number that is less than your x minus c, because that number is always negative, right? Because that's how inequalities work. Like you can see it up here, right? This side over here is negative, because that's how we got rid of the absolute value errors. Okay, so that's it for this section. Don't forget to do your homework for this week. If you have any questions, feel free to text, email, or call.